your parents ever told you, don't stare at the sun? Well, in today's video, we're going to be able to see directly into the sun with more details than ever before in this video from Astrum. Astrum is another favorite channel of mine. You should check it out. A lot of interesting, thought-provoking videos right here. We'll just get right into the video, but if you're into these type of thought-provoking videos, make sure you like this and subscribe to the channel for more. Your support means everything. Let's go.
When we look out into the vast, expansive, awe-inspiring cosmos, there are innumerable stars out there.
So incredible to just imagine, just within our own galaxies, just littered with billions of stars, and that's just one galaxy in our local neighborhood. With that many stars out there and that many planets rotating around stars, how could there not be more life? That's the question I ask myself. The odds seem so improbable. The odds seem so impossible that there's no other life forms out there somewhere.
Yet, one of them dominates our sky and our lives.
The life giver.
Burning brightly and ferociously at the center of our solar system, the sun. It's easy to see how generations of humans before us were inspired to create all kinds of legends to explain its mesmerizing glow.
I mean, if there was any other god to worship, this was it, because it was literally the life bringer to our whole planet. Everything that lives is a direct result of the solar radiation coming from the sun.
Now, as technology has advanced,
okay, let me correct that. Everything traces back to, because there is life deep underwater where the sun does not reach. And there is life that lives off of the thermal vents deep underwater. So, do they have a direct link to existing because of solar radiation? Actually, yeah, even them, because the seas would be frozen without the sun, right? Even if they're not receiving direct energy at the moment, the conditions that they exist in is because the sun, it keeps the planet warm enough for that to exist. But the core of the earth generates a lot of heat also. That's a very good question. I wonder, is absolutely every life form on this planet totally dependent on the sun? And if they're not currently dependent on the sun, is their environment or their condition for survival dependent on the sun being there, doing what it does? Let me know in the comments.
beyond the realms of their wildest imaginations, we can delve into the processes within and around our neighboring yellow dwarf, going deeper than ever before. As we journey through its ferocious atmosphere,
hot.
Let's explore what I'm sure you'll agree.
Look at this. This is crazy. Look at all those swirls.
Are the fascinating phenomena that materialize there. I'm Alex McColgan, and you're watching Astrum. And in this video, I want to dive into the sun, drawing on different wavelengths of electromagnetic energy to showcase the star in a new light.
Look at that.
Previously, we've explored Jupiter and some of its moons through the lens of the electromagnetic spectrum, which you can see in this video here.
Look at these bands over here. Do they mean that the temperature is much higher along these bands?
Today, we will be revisiting this approach, but this time, rather than a planet, it'll be adapted to investigate a highly energetic ball of plasma.
Okay.
The light we'll be looking at is old.
The light bringer.
Although light is the fastest thing we know.
Oh, yes. It takes a long time for light to get to the surface within the sun. Let's see what the number is exactly.
The image of the sun that we see from Earth is approximately 8 minutes and 20 seconds old.
Okay. It was referring to the time it takes from the surface of the sun to get to the planet. But I think even the time that light is created and has to bounce through the core and get to the surface is a long time.
Meaning we are viewing what the sun looked like a few minutes in the past. And if you count how long it takes the photons generated within the sun's core to make their way through each layer of the sun before escaping into space, the light that reaches us is anywhere from 10,000 to 170,000 years old.
10,000 to 170,000-year-old sunlight when you step outside and bask in the glory of the sun. It's ancient light. Ancient light. That's incredible to think about, right?
Where to begin? Like eating a fruit by starting with the outer layers and working your way in, let's start our investigation with the outermost layer of the sun's atmosphere, the corona. The following image was taken by the Solar Dynamics Observatory, or SDO, a NASA space mission launched back in February 2010. SDO aimed to better understand the solar variations that influence life on Earth and
which is super important because those flare-ups could mean mass disruption on Earth. Oh my God. Imagine all the satellites going out, power grids going out. Flare-ups could cause that.
And our technological systems by studying the dynamic solar surface and atmosphere at different electromagnetic wavelengths. By looking at light beyond the visible range, NASA was able to pick out normally invisible details crucial to our understanding of the sun. This image was taken using a 19.3 nanometer wavelength, representing light found in the extreme ultraviolet region.
How beautiful is that?
At a wavelength corresponding to a color temperature of 1 million Kelvin, we can clearly see the higher region of the sun's corona. Interestingly, the sun's
Look at how far-reaching that is.
corona can also be seen by the naked eye on rare occasions, such as during a total solar eclipse. When the moon is perfectly aligned between the Earth and the sun for a fleeting period of time, the view of the central, brighter disk, known as the photosphere, is fully blocked.
Have any of you actually watched an eclipse with your naked eye, your bare eyes?
Revealing a radiant exterior. While this is a breathtaking view already, the corona is still nowhere near as detailed as it is in this image taken by the SDO. This makes it a useful tool for scientists' studies. But let's go a little deeper, to features of the sun just beneath the corona. At a color temperature of 20 million Kelvin, the intensely vivid spots indicate events known as solar flares.
That's, my friends, that is a major problem. But luckily, our sun, our life giver, is relatively calm comparatively to others type of stars. But those flares, though, they happen. And if they get to Earth, it's a big problem.
Here is some footage of a particularly busy week for flares back in August 2022. I've always found solar flares to be both terrifying and hypnotizing. They are colossal explosions where the sun spews out an
Look at that. Look at those colors. And
immense amount of electromagnetic radiation.
wow.
They are caused when magnetic fields cross, distort, and reorganize themselves rapidly. This activity is created by the turbulent nature of the plasma within the sun itself, from which the fields ultimately originate. But they are not the only feature of the sun's atmosphere venting radiation. Coronal holes, indicated here by this darker region on the sun.
What is that? I don't think I've ever heard of coronal holes. Wow.
Are another fascinating feature which we'll take a closer look at using extreme ultraviolet light. Coronal holes are areas of cooler, less dense plasma
How could that even develop?
which are magnetically open, meaning that rather than forming closed loops that go back to the sun's surface, the field lines travel outward across the solar system. These areas allow solar wind particles to escape more easily into space.
And then that's how they stay a bit more cool, because all of that is escaping.
These solar winds are directed towards and collide with Earth's magnetosphere, beautiful auroral lights dance across the night sky at the Earth's polar regions.
Wow. How many of you guys have seen aurora lights in real life? I need to take a trip and see that before I leave this Earth.
Using ultraviolet light gives us a much better view of these fascinating features of the sun's outer layers. Non-visible spectrum light is an incredible tool, and there are so many different features in the sun's.
Yeah, it is so incredible that by isolating different wavelengths of light, we're able to see so much detail that would otherwise not be visible. Heck, even in situations where there's huge dust clouds in space and other things kind of blocking the view to something else, using different wavelengths, you could overcome that and see through different materials.
Outer layers to look at. There are solar filaments, known as solar prominences, the large loops of plasma that rise from the sun's surface. These enormous loops are large enough to make the Earth look like a tiny speck. Wow. And can stretch hundreds of thousands of kilometers into space.
Jeez.
They can form in as little time as a day, but a stable
Is that hell? that must be hell.
Prominence can remain in the corona for several months. In this example, we watch as a solar prominence snakes its way out of the photosphere and into the sun's atmosphere. Although this video is sped up so the minutes seem like seconds, when you consider the size of the prominence, it becomes clear how swiftly the sun's intense magnetic fields are causing this material to move.
Insane.
One fact you might not know about the sun's atmosphere is that it sometimes rains there.
What? How? It rains? What kind of rain? Is it raining lava?
Not all of the charged plasma fired into the sun's corona continues out across the solar system. Some remains in the corona, getting trapped and cooled until it falls back to the sun's surface as
that is incredible.
The shining rain. This coronal rain is beautiful to look at, but is best observed from a distance. It's still millions of degrees in.
It looks animated, like it doesn't even look real because of the path it follows is so neat. But obviously that's because of the electromagnetic field that's causing these materials to loop back around. It almost doesn't even look real.
In temperature. Of course,
it looks like some invisible thing is in the center and it's like liquid pouring down the edges.
Falling gently back to the sun's surface is only the fate of some of the sun's plasma. Wow. This is where the comparison to Earth fails. After all, on Earth, the clouds do not crack like a released elastic band firing into space.
Everything goes
on
back.
The sun, thanks to tightly wound magnetic fields, they do.
Jeez.
This is a time-lapse of a coronal mass ejection. Watch as the structure forms at the bottom left of the sun for some time, before eventually snapping and sending billions of tons of plasma out across the solar system. Even with the Earth's magnetic field, being hit by a powerful one of these could be devastating for our satellites and electrical grids.
Yeah, it's kind of the stuff I was talking about earlier.
All these structures are imaged by the SDO here, utilizing a 30 nanometer wavelength of light, which corresponds to the extreme ultraviolet portion of the electromagnetic spectrum. Timing is important when trying to image these features, as they are more common in certain years than in others.
What?
In fact, each structure is dependent on the solar activity of the sun.
Solar minimum and solar maximum. I guess this is when it's on sleeping and this is when it's fully awake and super active. Oh.
Sun, alternating around an 11-year solar cycle, which I did a video about here. But there's more to learn. Just as using visible and ultraviolet light shows us different things when looking at the same feature, using two different wavelengths of non-visible light can also be eye-opening.
Wow, you could combine them. Let's see what it looks like.
To demonstrate this, take a look at these two images of the sun's corona. Taken over the same time period, the following two images use different wavelengths of light. The first, imaged at a color temperature of 600,000 Kelvin, depicts the quiet corona and features coronal loops. The second, imaged at a color temperature of 2 million Kelvin, displays the much hotter active regions of the corona. The stark comparison between the two images highlights the importance of using different approaches when investigating the star. What may initially appear to be a singular solar phenomenon can be revealed as a complex, intertwined chain of events.
Wow.
And we still haven't technically made it through the sun's atmosphere yet.
Jeez.
Moving further inwards, let's look at another image produced by the SDO
This is all just on the surface so far.
utilizing a 160 nanometer wavelength of light, this time of the transition region. The transition region is a layer which sits between the sun's corona and the chromosphere, the lowest layer of the sun.
Chromosphere, 10,000 Fahrenheit to 36,000. Look at that density. Transitional zone gets even hotter at 40,000 Fahrenheit with twice the density. Wow. And the temperatures, corona sun atmosphere. The atmosphere is 2 to 3 million Fahrenheit. Oh.
Sun's atmosphere. It's a very shallow layer, approximately 100 kilometers in thickness. In this region, the thermal temperature of the sun rises dramatically from around 8,000 to 500,000 Kelvin. For an earthly comparison, fiercely scalding lava erupting in Hawaii is 1,170 degrees Celsius or 1,443 Kelvin.
That's nothing. That's so nothing. That's a freezer.
The temperature at the lower, deeper end of the transition region is almost 6 times hotter than this. At the upper end of the transition region, the temperature is more than 346 times hotter.
Wow.
Traveling even deeper, we find ourselves immersed in the sun's chromosphere, which is the last layer of atmosphere before we reach the sun's surface itself. Imaged here, using 170 nanometer ultraviolet light, it is estimated to be approximately 1,700 kilometers thick.
Wow.
Closely inspecting the chromosphere, we identify some mesmerizing features known as spicules.
Spicules. Sparkles. A whole lot of sparkles happening right here.
Swaying like long, wavy grass blowing in the wind, these long jets of plasma shoot upwards from the sun's surface at speeds up to 100 kilometers per second, approximately 282 times faster than the speed of sound.
Supersonic. Jeez.
And can reach lengths of nearly 10 kilometers, over 1 kilometer taller than Mount Everest.
Wow.
Forming and vanishing in around 5 to 10 minutes on average, the processes behind these spicules were widely unknown and debated for some time.
Could they be a result of the electromagnetic field? Like even a smaller inbound looping fields?
As it wasn't clear how magnetically charged particles could ever escape the sun's magnetic fields at that level. That is, until 2017, when a team of scientists working on an extremely detailed model of the spicules discovered that their origins must be related to neutral particles. Scientists had not originally included neutral particles in their models of the sun, as they didn't think they affected the motion of the magnetically charged particles. But
neutral particles? What is that? Someone explain that to me in the comments below, please.
Once they were added, it transpired that the neutral particles gave the magnetically charged particles unexpected buoyancy they needed to escape the sun's plasma and shoot up into space.
Could neutral particles just be ones that are not electrically charged?
Spicules. Descending further through the sun's lower atmosphere, we eventually reach the photosphere, the surface of the sun itself, which is best imaged using visible light.
All of that was just the atmosphere, and now we're just finally getting to the actual surface. Wow.
While the edge of the photosphere appears sharp and precise, as it often does to our naked eye, this is simply due to how far away the sun is. The sun itself is not solid at all. Since it is too hot for matter to exist in a solid, liquid, or gas state in any region of the sun, it can only be plasma, referred to as the fourth state of matter, and is estimated to make up 99.9% of all the matter in the universe.
What? Oh, because most of the matter is within stars. Is that why?
Plasmas tend to behave a lot like gases, except they are made up of a mixture of ionized atoms and free electrons. The photosphere is the outermost layer in this image, around 400 kilometers thick. It is not a fixed, solid boundary of the Sun, unlike what this image may suggest. And sadly, it is the deepest layer of the star, which scientists can measure directly.
Damn.
At a closer look, you may notice some dark spots on the left-hand side.
Those? What are these? What are those?
These are known as sunspots and appear darker than other parts of the photosphere due to their
Sun pimples.
cooler temperatures. But that's only in comparison to their scorching hot surroundings. Unlike coronal holes, sunspots form in areas where magnetic fields are particularly powerful. Here, heat becomes trapped beneath the photosphere due to decreased convection within these areas. When comparing this image of the Sun to a previous one
So there's less material rotating and it causes a slightly cooler temperature in these spots.
taken using extreme ultraviolet light over the same period, a connection between sunspots and solar flares emerges. The captivating solar flares and sunspots coincide at the same location. From peering beneath the surface, it becomes clear that one must lead to the other.
It's a good maybe canary in the coal mine to know when flare weather predictions for the sun flares.
Now, let's take a closer look at some similar sunspots. This image was taken using the Swedish Solar Telescope, based here on Earth, and using a wavelength of visible light of approximately 400 nanometers.
Wow.
Next to and surrounding the sunspots.
And this is all plasma. It looks like, you ever look closely on a leaf? This looks like those little patterns that you see on a leaf if you look at it closely or if you zoom into it.
The photosphere is saturated with these jagged-edged, endlessly shape-shifting cells, which doesn't look dissimilar to lava as it cools and cracks. However, these cells are around 1,000 kilometers wide and are known as solar granules.
1,000 kilometers wide.
Consider them from the top layer of a churning convection cell underneath. Brighter areas inside each granule represent fluid of unimaginable temperatures rising from within the sun's upper interior layer to its surface. Upon reaching this boundary, the fluid has nowhere to go except to spread outwards and across.
Wow.
After cooling gradually, the fluid sinks back inwards via the rough, dark boundaries surrounding each cell, before repeating the cycle. This process closely resembles the convection currents within the Earth's mantle, responsible for driving plate tectonics.
Look at that. It does. That's similar to the process of even a volcano.
This process is no joke. While on average it is estimated that each granule lasts for as little as 20 minutes, the flow within the cells reaches supersonic speeds of more than 7 kilometers per second.
What? Supersonic hot plasma bubbling to the surface and sinking back. That's what we're dealing with here, folks.
Generating waves on the sun's surface due to sonic booms.
It's generating freaking sonic booms on the sun's surface.
Fascinatingly, these granules can also be seen in the full disk view we saw earlier, utilizing the same wavelength of visible light.
Picture volcanoes were moving at that kind of speed. Oh, man.
You may think this image looks quite grainy for such a high-tech space probe. And you're right, it does. But that graininess is the granules on the photosphere of the sun, not a processing effect or excess noise in the image. And that's it. Sadly, our journey ends here.
What? We can't see deeper? I wanted to go deeper and deeper and deeper, all the way to the core.
As scientists have not yet figured out how to image deeper into the sun, using either visible or non-visible light.
Boom.
Much of what lies beyond this layer remains shrouded in mystery.
Wow.
But we can see the benefits of using light of all different
Oh, that's pretty cool. Rotating all the various imaging in different light spectrums. Wow.
spectrums in our study of the sun. They help us observe exploding solar flares, vast coronal holes, swaying spicules,
That is so trippy. It's like little
flares,
hairs.
vast coronal holes, swaying
Look at these, like little hairs on the sun. The sun is hairy, people.
spicules, intriguing sunspots, and shape-shifting cells, just to name a few, in completely new ways. The sun is abuzz with lively activity, and so much of it
It looks kind of a mess in this image, right? With all that's going on, it looks messy as hell.
would be invisible to us were it not for these imaging techniques.
Thank you for this existence, this universe, for creating the whole spectrum of light that we could actually tap into and see so much. Oh my God. Without light, we would not have any idea how the universe existed. All that evidence that's coming into us, the CMB. Oh my God. Thank God for light and its eternal ability to just last forever.
Maybe one day we'll find ways to see deeper, using techniques we can barely dream of currently, just like those ancient generations of humans long ago could hardly dream of the methods we're utilizing these days.
True.
But for now, just knowing there is so much going on unseen in the universe, and knowing we have the means to uncover it, fills me with excitement and curiosity. Who knows what else might be out there, waiting to be found.
All right, so that was the end of the video. Very, very exciting images, seeing the sun like we never seen it before. Did you expect any of these images to look like what they do? And what did you learn about the sun? And aren't you thankful that the sun is, relatively speaking, calm compared to other stars? I know I am. The scary part is those sun flares. That could cause so much damage and set us back to the Stone Age, really. And we're not even really prepared for those, really. I don't think there's much investment happening to protect electrical grids from something like that. But I guess it needs to happen and cause mass destruction before people take it seriously. Anyways, if you enjoyed the video, make sure you hit the like button. Thank you for watching. I appreciate you. Make sure you also subscribe to support this channel so I could put out more videos like this. See you in the next one. Mecca out.